Good morning, everyone. My name is Sugandham. My roll number is 2051 80231. My branch is Tripoli. My subject is Principles of the Signals and Systems. My topic is implementation of low cost wireless multi channel surface EMG acquisition system. Electromagnograms signals have attracted much attention and have been applied widely. EMG signals have been used to evaluate the functional status of skeletal muscles. The commercial EMG acquisition systems are costly, as many researchers have provided low cost solution. All through the wireless acquisition systems are realized the transmission speed is not sufficient for the high sampling and multi-channel measurement. The pressure of this work is to implement a low cost and wireless surface EMG acquisition system separating the high sampling and multi-channel measurement. The purpose of this work is to implement a low cost and wireless surface EMG acquisition system supporting high sampling and multi-channel measurement using variable EMG sensor combined with a microcontroller unit and a Wi-Fi module. The measured surface EMG signals sample can be forwarded immediately to the host for the further processing and additional applications. Besides, the proposed the system has validated by applying the commercial EMG detection system. The results show that all the correlations coefficients are over zero point 0.8 that represent moderate to high relative agreement between the commercial and the proposed system. Introduction. With the progress of science and technology, people pay more and more attention to their health. In addition, recently the Internet of Things is closely related to our lives. Therefore, the development of the consumer medical and electronics has also been driven. One of these important bioelectric signals is the electrical manifestation of the human muscles known as EMG signals. EMG instrumentation is described as a device for recording the muscle activity and it can be used to measure the changes in electrical potential between 2 points of a muscle using EMG electrodes connected to those 2 points. EMG signals have been used to evaluate the function status of skeletal muscles and assist of neuromuscular training and rehabilitation. May applications include rehabilitations in various conditions as well as in specific fields such as kinesiology and biomechanics. EMGs can also use to analyzing muscle dysfunction, detect the improperty, muscle activation presence and will as so assist in establishing and assessing a treatment. Nowadays, there are two ways of EMG signal instrument, including intramuscular EMG and surface EMG. Intrascalar of EMG signals are detected with a needless or wireless inserted in the muscles. Assessing muscles functions by recording the muscle's activity from the surface above the muscle on the skin. Considering the health risk and accessibility, much of the current myoelectric control literature focusing on developing surface signals. We can see the flowchart of this. We can work in this way. The purpose of this paper is to implement a low-cost EMG acquisition system for the high sampling and multi-channel measurement. Considering the a portable application, the EMG signal detecting can be achieved through utilizing wireless technology. 2G and 3G is costly and high power consumption, and the data rating of LoRa and Zigbee and BLE is not enough to realize the high compiling and multi-channel system. Wi-Fi is the most common wireless transmission technology in our daily life. Such is connected to mobile phones and laptop and so on. It, it is a low cost and it can connect to up to 30 nodes. Besides, the data rate can support the proposed system. In the in this research, EMG consequential systems are divided into two parts: measurement modules and host. The Wi-Fi transmission technology is integrated in each measurement module. Each measurement module will connected to wireless router and making a LAN with the host. Meantime, the host GUI is designed receiving and decode the EMG data to achieve the multi-channel detection. Therefore, the number of channels depend upon the router connection capacity that the maximum channels are around 30. We can see we can connect the EMG's measurement modules for the muscles. We can get the signals from the skeletal muscles to it can be connected to the Wi-Fi router. It can be decode that GIU can decode that signal. Implementation method. The EMG classification system relies the processing of and recording of the surface biological signal. The bioelectrical signals acquired from the skin surface of human skeletal muscles are transformed into digital signal sequence which are transmitted to the corresponding processing unit after amplification, filtering, and other processing. In this paper, the proposed system is composed of two parts: measurement modules and the host. The measurement modules capture the analog EMG signals through surface electrodes on the skin over the muscles of internets, and this transmit of EMG data was using the wireless for further processing. Measurement module design. The architecture of EMG measurement modules, the illustrated of the weak EMG signals from the skin surface of human muscles are located, collected, and through the muscle sensor amplifying and filtering the muscle sensor unit. After amplifying the filtering, the EMG signal passed through the ADC sampling. In the MCU, we get original EMG sequence. Moreover, the digital signals will be sent a Wi-Fi module using the UARTA interface. The Wi-Fi module transmits EMG signals computers with CTP/IP protocol stack. Whole system using the 300 mAh lithium battery and main power supply. EMG sensor unit. EMG sensor signals can a statistical nature. The amplified of the EMG signals can be ranged from 0 to 1.5 MVA. Without using the EMG sensors, the analog EMG signals are too weak to directly convert into digital data from MCU. The EMG sensor amplified the filters and analog EMG signals, recording the skin and output signals with sufficient strength for the digital conversion. Central control unit. Ultra flow control URTA is asynchronous and this paper. Hardware flow control has instructed into the proposed system to solve the data less than when transmitter, sending the router, generating and receiving the rate. Software implementation of this flow of the central control unit and divided into three sub-processes. Sampling the EMG EMG signals are ADC. The MU is data transmission. That a case study design in the commercial device and proposed design. Conclusion of an decision in the low-cost wireless multi-channel EMG section system was developed. The EMG's variable sensor, ADC lithium battery, and the wireless transmission technology were integrated at the EMG activation device. Moreover, the experimental result showed that the both systems have a moderate high correlation and can be used for analyzing process EMG signal, which create the system and research of following the EMGs. Thank you everyone.